students. So in this lecture we will be discussing about gamma functions. Now gamma function is given as represented as 0 to infinity to the power minus t into t to the power z minus 1 dt, and it is also written as equal to z minus 1 factorial. The reason is z factorial is equal to 0 to infinity e to the power minus t to the power z dt. So since here is to the power z, so z factorial, here is to the power z minus 1, so z minus 1 factorial. Now this gamma function is one of the most widely used special functions in advanced mathematics, and it appears in almost every integral and every series representation. Now there are some relationships of gamma functions, like gamma z plus 1 is equal to z factorial. This is quite obvious because if we replace z with z plus 1 here, then it will be this will be simply expression will convert to this expression, and so we obtain the z factorial. Now we will try to prove it in a different way. We know that integration by parts, integration u dv is equal to uv minus v du, and basically the equation is integration uv is equal to whatever, let's say integration uv, I'm not say t whatever, I'm not taking that part, just for symbolically I'm written is integration uv is it keeps the first function as it is, integrate the second function, and then you take the differentiation of the first function and you integrate the second function and you integrate the total function. So this is the whole. So instead of writing here uv, so we have replaced this v by dv, so everything else is same. So this is the expression that we are getting. Now what we will do in this expression, we will replace u by t square. Let's say u is equal to t square, and so this will imply that du is equal to not t square, t to the power z, to the power z. So du will be z t to the power z minus 1 dt, and we will take dv, this one, as equal to e to the power minus t dt. That means So v becomes equal to e to the power minus t. Now we will use these expressions into gamma z plus 1. We will put these expressions here. So by doing that, we get gamma z plus 1. No, put the let's write once again what is the gamma function. Now gamma function, gamma z is again 0 to infinity e to the power minus t to the power z minus 1 dt. Now we are writing gamma z plus 1. So it will be again 0 to infinity e to the power minus t, and replace z by z plus 1. So it will be t to the power z dt. So if you again integrate with the integration, so it will be minus e to the power minus t to the power z 0 to infinity plus z 0 to infinity e to the power minus t to the power z minus 1 dt. Now given the restriction of z greater than equal to 0 for the integer form of the factorial function, it can be seen that the first term of the above expression goes to 0. So this term will be equal to 0. So that is when t is equal to 0, t to the power z will be equal to 0, and when t is equal to infinity, then e to the power minus t will tends to 0. In both the cases we are getting a 0 value. So the first term cancels out, and then we are left with the second term. So we can simplify this. I can simply write, so we can remove all these. We can simply write gamma z plus 1 is equal to the following expression. Now, so z minus 1. So this expression is nothing but gamma z. So that means this is equal to z gamma z for z equal to greater than 0. So when z is equal to 1, then t to the power z minus 1 is equal to t to the power 0 is also equal to 1. So we can write gamma 1 is equal to 0 factorial, and it is equal to 0 to infinity e to the power minus t dt, and which of course we do the integration, that is minus e to the power minus t 0 to infinity, so it also equals to 1, so this is equal to 1. And for the other terms, so we know that now gamma 1 is equal to 0 factorial is equal to 1, and gamma 2, we know that gamma z plus gamma z plus 1 is equal to z gamma z. So gamma 2 will be equal to 1 gamma 1, and that will be again 1 into 1 factorial, that will be again 1. Similarly, gamma 3 will be equal to 2 gamma 2, so it will be 2 into 1 is equal to 2. Gamma 4 will be 3 gamma 3, so 3 into 2, which is equal to again 3 factorial. So in general, we can simply write gamma n plus 1 is equal to n factorial, where n is 1, 2, 3, a natural number. Now, based upon this gamma function, there is a formula which is called duplication formula. So according to duplication formula, 2 to the power 2z minus 1 gamma z plus 1 by 2 is equal to root pi gamma 2z, and this is the duplication formula. There is another reflection formula. So according to reflection formula, gamma z into gamma 1 minus z is equal to pi by sine pi z. Now we have till now we have found the gamma function of natural numbers. What about integral multiples of 1 by 2, half integrals? So like gamma 1 by 2, what is the value of gamma 1 by 2? And gamma 1 by 2 is again equal to 2 into 0 to infinity e to the power minus y squared dy, and it is equal to root pi. So we can say that gamma 1 by 2 is equal to root pi. So gamma, what will be gamma 3 by 2? Now we know the relation gamma z plus 1 is equal to z gamma z. So gamma 3 by 2 will be equal to half into gamma 1 by 2, which is equal to root pi by 2. So that is the next relation. Gamma gamma 3 by 2 is equal to root pi by 2. Similarly, gamma 5 by 2 will be 3 by 2 gamma 3 by 2. So that will be again equal to 3 by 2 into root pi by 2, and that is 3 by 4 root pi. So this is the value of gamma 5 by 2, and it continues. So ultimately we can say that gamma n plus 1 by 2, there is a relationship which is equal to which is equal to 1 dot numbers 1 into 3 into 5 till 2n minus 1 divided by 2 to the power n into root pi. So n is equal to 1, 2, 3, dot, 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 dot. This is one relationship of gamma function. Now, apart from gamma function, there is one more important function, which is called beta function. Expressed as beta, and it has two variables a and b. So we can present beta function as equal to 0 to 1 t to the power e minus 1 into 1 minus t to the power b minus 1 dt, where a is greater than 0 and also b is greater than 0. This is expression for gamma function, beta function. Now there is a relation between beta and gamma functions. To find our relationship, we need to first introduce the value u, which is equal to t divided by 1 minus t. That is basically we are getting it t into 1 minus t to the power minus 1. So if we put that value inside, if we try to express the beta function in terms of this u, then the beta function can be written as equal to 0 to infinity u to the power a minus 1 divided by 1 plus u to the power a plus b du. So we once again write the expression here. Beta ab is now 0 to infinity u to the power a minus 1, divided by 1 plus u to the power a plus b du, and of course here a is greater than 0 and b is greater than 0. Now there is an expression 0 to infinity e to the power minus pt to the power z minus 1 dt. That means we have simply introduced this extra p here in the gamma function, and so by introducing it, the gamma function e changes by gamma z to the power p to the power z. Now in this expression, if we put p as equal to 1 plus u and z as equal to a plus b, then we get 1 by 1 plus u a plus b. You can express it in terms of 1, so let's try it in a different way. We can represent 1 plus u to the power a plus b as equal to 1 by gamma function of a plus b into 0 to infinity gamma a plus b into 0 to infinity e to the power t minus t to the power a plus b minus 1 into dt multiplied by 0 to infinity I to the power minus ut u to the power e minus 1 du. So this expression this expression is nothing but this expression is nothing but gamma a. So we can write this as equal to gamma a divided by gamma a plus b into 0 to infinity e to the power minus t to the power b minus 1 into dt, and it is equal to gamma a gamma b divided by gamma a plus b. So this is how you can express. So this is an expression how gamma can be expressed in terms of a beta function. Now there are other ways of representing the beta function. Like beta function can also be expressed in the following manner. So beta AB can be represented as equal to 0 to infinity u to the power a minus 1 divided by 1 plus u to the power a plus b du. When we are replacing t by u by 1 minus u, and if on the other hand if we replace t by sin squared theta, then again we can represent the beta function as equal to 2 into 0 to pi by 2 sine to the power 2a minus 1 theta into cos 2a minus 1 theta d theta. So this is another way of representing the beta function. Now this is called the beta integrand. This is called the beta integrand. Either this or this is called beta integrand, on which the integration is done to calculate the beta function. Now this the application of beta function is used to estimate the average time of completing selected task in time management. So average time in completing certain tasks. So this is all about beta and gamma function.